Okay, so we are talking about MLOps, machine learning and operation. This is module 5, part 2. The first, as we said, that there are 3 dimensions for the 3 stages, phases for the MLOps. First is the design, second development, and then deployment. Let's focus on the design. The design is focused on the added value, the business requirement, key metrics, and the data processing. The design especially focus on the essential business requirements for the machine learning project. For example, focusing on the end user, who is the end user, understand the need of this end user. For example, also the speed of the prediction, how fast you want the user want the decision, like prediction or classification or any other decision that the machine learning will make. The accuracy also, how accurate is that? Which level of accuracy you want? Is it like 99% of accuracy or 95% of accuracy is enough? Transparency. If you remember in the second module, we were talking about governance and the transparency and explainable AI. So how transparent the decision? Is it like they just give you the decision or explain the decision also how you reach this decision? Compliance and regulations. Is there any regulation to be taken off or not? The budget, how much budget you have, how much budget, how much will be the cost of this solution, and then team size, how many developers you have, and expertise, which expertise you have. So the key metrics for the design phase is that identified by the data scientist, the subject matter expert, and the business stakeholder, and these are the players, and you are focusing on customer happiness and which value you will get by implementing this kind of application and the accuracy. If you remember also, we were talking a lot about data quality and ingestion, and the data quality is very important here during the data processing. How the data quality is considered during this phase is very important to be considered here. The quality of the machine learning model is also very important and highly dependent on this data quality. Data quality dimensions, for example, if you remember also in module 2, we were talking a lot about these dimensions: accuracy, completeness, consistency, timeliness. These are some examples and the dimension of the quality that available. For example, does our data is correctly described to the customer or not? These are questions you have to answer. We have the next phase is the development phase. And during the development phase, we have several things to be considered. For example, the feature engineering in the machine learning and the data science takes a lot of feature engineering, makes a lot of decision about feature engineering. Feature engineering is selecting or modifying and transforming raw data into new features or few new variables, new meaning variables. Sometimes 2 row or 2 column of your data doesn't mean anything, but when you take them both together, they give a new meaning, a new row of data. This is very important. You can generate a new feature for this and to be considered in the machine learning model. So this is very important. Sometimes more feature is not good also. Sometimes more feature is good. So it depends actually. More feature can produce accurate a model, more stability, but sometimes it's expensive and needs more maintenance. And sometimes adding more feature will add more noise to the data. So if you do a lot of feature engineering and you have big data, huge data with the model and everything, sometimes nowadays a very new thing available in the clouds and in the several services, which is the feature store. The feature store is the storage of the frequent use of the features. So if you are doing a lot of feature engineering and you don't want to do this again and again, it's better um, to store these things, these features in the feature store. And this is if the feature engineering is costly for you, this will reduce the cost sometimes. But also, if you want to add the feature store um, into the service, maybe that will cost also. So it depends how you want to use the feature store or not. It's not a must, but sometimes it's very useful to be considered and to be used, the feature store. If you do a lot of feature engineering, sometimes you can come back to this feature without doing feature engineering. You take the feature that you made by the feature engineering. Experimental tracking is very important during the development process. And so experimental tracking can help to, for example, comparison and evaluation. So if you do the experimental tracking between a model to another model, you will be able to compare and see which model is good and why. Reproducibility, of course, if I have the results, I can replicate and see if this is correct or not. If I send it to another developer, for example, this is also very important for the collaboration because I can see what you have done and what are the experiments you have done. Reporting, very important, of course, for the stakeholders. When you do the experimental tracking, you give the report to prove that this has been done for your stakeholder. Finally, the deployment. There are several things to be considered in the deployment phase, which is, for example, the runtime environment. The runtime environment is sometimes there are two environments. So one is the development environment, and sometimes it's um, the first is the development environment, and the other one is the deployment environment. The development environment is the environment that data scientists typically use. For example, it's Python or it's in the cloud, whatever. It's a development. You use it for the development of the model and for the experiment, for the testing, and so on. Production environment, when you put this model into production, and this will handle the actual data, the live data, and the actual model, and making the prediction. The problem is that sometimes these two environments um, are different. So the runtime environment, when you go from the development to production environment, the um, is very problematic because the runtime environment sometimes is not the environment um, that you develop the model. So that's why, if you remember in the last module, we were talking about this containerization. So if, for example, you use Python 3.6 during the development and the runtime environment, the production environment, um, Python version is 2.8, sometimes it's crash, it doesn't work. So for dealing with this, as we said, we mitigate the runtime environment by using different things. For example, um, you you make identical setup. So if the during the development your Python is 3.2, then the runtime environment should be exactly the same to avoid these problems, compatibility problems. But sometimes, as we mentioned before, you want to use virtual machines. And also this is very important to use virtual machine, and your hypervisor, the physical hardware, you don't care about this. You have virtual machine over on top of them, and you can install whatever you want in the virtual machine. Or the most important thing is the containerization. So you containerize everything and you don't care about the um, compatibility and those things. So once you have you have everything and you want to deploy, also there's a very important thing during the deployment process, which is the architecture. Which architecture you use? There are basically different deployment options. For example, you have um, yeah, for example, this is a kind of shopping problem here for payment service, shopping cart, and so on. So there are two options here. One option is for this kind of application. One option is a single instant that you want to run all the service on the same computer. And monolithic architecture here is that building a single unified application that encompass all the services on one computer, for example. Um, so this has pros and cons, of course, and also the most important and new thing is the microservices architecture. Small independent services that are located not on the same device, but on different instance, different devices, for example, sometimes. There are a lot of advantages. Is one of the thing is the isolation, and but sometimes it's very costly because it needs you bring services from many places. Sometimes you need computation and so on. You know, sometimes you have to buy the service or buy money. Monolithic architecture is a single unified application that contain everything. But the good thing is that it's very simple to, not very, but it's simple and cost effective. Disadvantage, of course, we know that is a single point of failure. So if something happened, then everything will collapse. But the thing is, this is something you have to decide as a designer or as a MLOps or a MLOps specialist or a AI engineer. Inference, finally here, inference is, as we mentioned before during the last module, we have the API and we inference during the API. Inference is the process in which we send new input to the machine learning model, and then you receive the output, the decision. So you send the input and you get the decision through the API.